Alright, the next problem that I'm going to do is number 6 on your notes. So I'm going to start this problem very similar to number 1. I'm just going to expand by using those properties that we talked about in the front. So this is going to equal the limit as x approaches 0 of tangent of 2x over 1 times 1 over sine of 7x. Now, if you notice from our trig identities, I can actually rewrite tangent of 2x as sine of 2x over cosine of 2x. So I'm going to go ahead and do that now. So this equals the limit as x approaches 0 of sine of 2x over cosine of 2x times 1 over sine of 7x. I'm going to expand it even farther by separating the sine of 2x and cosine of 2x, very similar to what I did, how I separated tangent of 2x and sine of 7x. So this is going to equal the limit as x approaches 0 of sine of 2x over 1 times 1 over cosine of 2x times 1 over sine of 7x. Okay? Now, by the squeeze theorem, we know the sine of 2x will go to, as I substitute 0 in, as long as there's a 2x in the denominator. So what I need, Okay, I know I need to multiply by 2x. Oh my god, I'm going to kill this thing. 2x, okay, in the denominator, because I want that 2x to go right there. But again, remember, I can't just multiply by 2x. I have to multiply by something equivalent to 2x. So I'm going to put equivalent to 1, so I'm going to put 2x in the numerator. Okay? Well, if you notice, I also have another sine of 7x. And I want a 7x in this numerator to go. So when I evaluate that limit as x approaches 0, it'll also go to 1. So I need a 7x in my numerator, but again, I have to multiply by 7x in my denominator, so it's equivalent to 1. So this 7x is going to go directly here. So let's figure out what I have. This equals the limit as x approaches 0 of sine of 2x all over 2x times 1 over cosine of 2x times 7x over sine of 7x. And if you notice, you're left with 2x over 7x, because this 2x in the denominator went there, and this 7x went to this numerator. So you're going to be left with this 2x and that 7x. Okay, if you notice, those x's will cancel, and 2 over 7 again is a constant. So I can move this entire constant by the properties that we talked about in the first page out in front, because it's just a multiple. So this now becomes 2 over 7 times the limit as x approaches 0 of sine of 2x over 2x times 1 over cosine of 2x times 7x over sine of 7x. Now, what a lot of people normally get confused on, they want to multiply also by 2x. So you get 2x over cosine of 2x. But remember, side note, when you evaluate the limit as x approaches 0 of 1 over cosine of 2x, you can just directly substitute it. You're not going to get 0 in the denominator. It'll be 1 over cosine of 2 times 0, which is 0. Well, cosine of 0 is 1. So that's why we don't need to multiply the numerator by anything, because 1 over cosine of 2x or cosine of 2x, by direct substitution, it's already going to go to 1 when I substitute 0 in there. Okay? So, now we're going to use our properties. I'm going to drop down to 2 over 7. By the squeeze theorem, sine of 2x over 2x is going to go to 1. That's a direct application. And as well as 7x over sine of 7x, that's also going to go to 1. So 1, and then again, cosine, 1 over cosine of 2x by direct substituting 0 in there from over here, that's also going to go to 1. And then 7x over sine of 7x is also going to go to 1. So I multiply those all together, I get 2 over 7. That's supposed to be a 2. Okay? So basically, when I go through these problems, and I find how many signs I have after breaking all these problems off. Okay, so if I have 2 signs, I know I'm going to be multiplying by 2 fractions that are equivalent to 1. Like in the previous problem, I just have sine of something, so I multiply by 1 fraction. Okay. So hopefully this helps. please try to complete the rest of the notes, and I will help you tomorrow if anyone needs it. Thank you.